Okay, so we're going to talk about the functions we talked about yesterday in the graphic organizers, and then we're going to talk about a little more details about them, and then learn about how to do average rate of change of a function, which we had mentioned in a lesson a couple weeks back, but we're going to go over in more detail. So think about the two functions you studied in the previous activity. Here they are. Compare the two functions. Show your work and explain your reasoning. Which function has the lowest minimum point? So the lowest minimum point, these are both parabolas. They both open up because they have a is positive. So we know they're going to have a minimum. To find the lowest minimum point, you're going to find the vertex. To find the vertex, you're going to use the axis of symmetry. Okay, to find the x value of the vertex, and then you're going to substitute that value in to find the y value. Okay, so that is our process to figure out the minimum point. So find the axis of symmetry, plug the x value in to get the y, that is your vertex. You're going to find the vertex of each and figure out which one is lower. So for then b, which function has a greater value at x equals 8? So you're going to go with f of 8. And you're going to go to the f function and plug in 8. So 8 squared plus 2 times 8 minus 3. And then you're going to solve that equation. 64 plus 16 minus 3 is 77. So that's the value for f of 8. You're going to do g of 8. And then you're going to figure out which one's value is greater. For c, which function has a greater value of x is 9? You're going to use the same idea. F of 9 equals 9 squared plus 2 times 9 minus 3. Simplify that. Make sure you're using order of operations correctly. And then you're going to do the same thing for g at 9. And you're going to compare which one is greater. So now I get to average rate of change. So for average rate of change, the rate of change of a quadratic function is not constant. We've talked about that many times. So it's not constant. A linear function has a constant rate of change. So to do rate of change for a quadratic function, we use average rate of change between 2 points on the quadratic equation. So you're going to take 2 points on your parabola. So whatever 2 points it talks about, and you're going to think of this as a line going through them. And find the rate of change of that line or the slope of that line. And that's going to tell you the average rate of change on the interval from that one point to the other. So we think of it as a change in the y value, f of x, over the change in the x. The best way to do this is to find the coordinates, a, f of a, and b, f of b. And then here's the formula if you want to use the formula. I like to do slope differently, so we'll look at that as we go. So on the interval 0 to 1. So in order to do the interval 0 to 1, we have to find the value of the function at 0 and the value of the function at 1. So when the value of the function at 0 is your y-intercept, since this is in standard form, we know it's going to be -3. And the value of the function at 1, we're going to have to substitute. So 1 squared plus 2 times 1 minus 3. 1 plus 2 minus 3 is 0. So our coordinates are 0, -3, and 1, 0. So to find the slope, I like to just think of change in y. So went from -3 to 0 is up 3. Over the change in x, 0 to 1 is up 1. So the slope or the average rate of change for this interval is 3. Okay, so now let's do the same thing over here. We have the 0. And then 1. Those are the values we need. 0, again, is going to be the y-intercept. We plug in 0, we get -30. To do 1, we're going to do 2 times 1 squared minus 4 times 1 minus 30. 2 minus 4 minus 30 is -32. So our change is -30 to -32 is down 2. 0 to 1 is up 1. So the change would be -2. Okay, then it says 0 to 2. Well, we already know the 0 value, so we can put that there, but now we've got to do if it's 2. So we're going to plug in 2 squared plus 2 times 2 minus 3. And we get 4 plus 4 minus 3 is 5. So now we're going to our rate of change from -3 to 5 is up 8. From 0 to 2 is up 2. So this would be 4. And then over here, again, the 0, negative 30. The 0 doesn't change. We need to do 2 instead of 1. So we're going to plug in 2 times 2 squared minus 4 times 2 minus 30. And we get 2 times 4 is 8. Minus 8 minus 30 would just be negative 30. So again, negative 30 to negative 30 is a change of 0. 0 to 2 is a change of 2. 0 over 2 is 0. Okay. And then you do 0, 3. Again, you know the 0 value. Now you have to do the 3 value. And over here, we know the 0 value. You need to find the value for 3. So I'm going to let you do these on your own. You're going to plug in the 3 just like we did here and solve, and that's going to become your coordinate, and then find the slope. 4, 5, you're going to have to plug in 4, and then you have to plug in 5 separately, and then 4, and then 5. I'll do this one for you, and then you'll be able to do that one. So if we're doing 4, we're going to plug in 4 to this equation. We get 4 squared plus 2 times 4 minus 3. So 16 plus 8 minus 3 would be 5. And then 5 squared plus 2 times 5 minus 3 is 25, plus 10 minus 3 is 32. So again, the change in y, 5 to 32 is up 27, and 4 to 5 is up 1. So this rate of change would be 27 over 1, or 27. So now you're going to follow that same pattern, but use this equation and find the value here. And then there's a question at the bottom you can think about and write an answer to. All right, and then after you finish that, there's a worksheet that you're going to do average rate of change on the interval it tells you for each problem. Some they give you the graph. Some of them they give you the points.